Welcome to The Explainer. Today, we're going on a little time-traveling journey. We're going to trace the absolutely fascinating evolution of computers, specifically how they went from these massive, heat-generating, room-sized behemoths to the lightning-fast little chips that basically power our entire world today. It's really a story of just incredible human ingenuity, where every single time we hit a massive physical roadblock, we countered it with an even more spectacular technological leap. So here's our roadmap for today. We'll kick things off by redefining what a data processor actually is, and then we'll march straight through four explosive generations of tech: vacuum tubes, transistors, integrated circuits, and finally, the almighty microprocessor. All right, let's dive right into part one, the ultimate data processor, redefining the machine. Before we jump into the history, we really need to set our baseline. Now, you hear the word computer, and you probably think of, well, computing, like a giant math calculator, right? But modern systems are way more than that. Actually, get this, over 80% of what they do today isn't even numerical. It's gathering data, merging records, sorting data sets, and printing. So honestly, a much more accurate name for these machines is data processor. And when you really look at their core superpowers, beyond just raw speed and accuracy, there's one trait that totally steals the show, and that's diligence. Think about it. Unlike us humans, a processor doesn't get bored, it doesn't need coffee breaks, it doesn't suffer from fatigue or lose its focus. If you give it 10 million tasks to do, it's going to execute that 10 millionth task with the exact same pinpoint precision as the very first one. But there is a catch. They're strictly automatic. They are 100% dependent on us, on the quality of human programming and the data we feed them. It's that classic saying, right? Garbage in, garbage out. If you give a computer imprecise logic or bad data, it's just going to use all that incredible diligence to process your garbage into, well, equally flawed garbage output. So, to understand how we got to where we are today, let's take a look at this timeline. We usually break computer history down into generations, which is really just a handy way to track the massive leaps in hardware and software. As we go through these, pay attention to how each era basically swoops in to rescue the industry from the totally crippling limitations of the one right before it. Which brings us to part two, Generation 1, vacuum tubes. We like to call these guys the fragile giants. Okay, picture it. It's 1942, and early computing is running on these super fragile glass vacuum tubes. They used little filaments inside to control electronic signals. And hey, at the time, they were the fastest things around. The problem? A single computer needed tens of thousands of them. And since each one sucked up about half a watt of power, these machines generated an absolutely unbelievable amount of heat, like literally room-baking temperatures. Honestly, the physical hurdles here were just a nightmare. I mean, these machines were the size of a room. They needed constant, heavy-duty air conditioning just so they wouldn't melt themselves down. And worse, those glass tubes, they burn out all the time. The system would just crash constantly. Oh, and get this, every single one of those thousands of components had to be hand-wired together. Plus, you had to be an absolute genius to even use one, writing code in insanely complex machine languages. As you can guess, trying to produce these commercially was basically impossible. Something had to change. And that brings us to part three, Generation 2, the transistor. This is where we get our thrilling rescue. Right around 1955, the folks over at Bell Labs delivered a total game changer, the transistor. They took that fragile, hot glass and replaced it with rugged, solid germanium semiconductor material. No more filaments burning out. These things were rock solid. They used literally a tenth of the power, barely produced any heat compared to the tubes, and to top it all off, they were 10 times faster. Just a massive, massive leap forward. And because the hardware was finally cool and stable, software could take a giant leap too. We started seeing high-level programming languages like Fortran and COBOL. Suddenly, humans didn't have to write encrypted machine code anymore. We also got batch operating systems. Instead of a person manually feeding in one task at a time, you could just batch a bunch of jobs together, and the computer would automatically churn through them. This was huge, guys. It meant computers could finally escape the science labs and start doing real commercial work for businesses, like running payroll and tracking inventory. Let's keep moving. Part 4, Generation 3, integrated circuits, also known as the Silicon Leap. Even with transistors, we still had a problem. People still had to wire them together by hand. But by 1958, engineers figured out something straight out of science fiction. They invented the integrated circuit, or IC. Instead of manually wiring individual parts together, they actually figured out how to grow multiple components like transistors and resistors directly onto a tiny 5 mm square of silicon. Boom, no more hand wiring. I cannot overstate what a breakthrough this was. By printing the circuits right onto the silicon, that massive bottleneck of manual labor just completely vanished. Naturally, computers got way cheaper to build. This era, stepping into what we call small and medium-scale integration, meant these machines were rugged, sipped power, and were crazy fast. We're talking about hitting 1 million instructions per second. It literally birthed the mini-computer, which drove costs down so much that normal, everyday companies could finally afford to have their own computing power. And of course, the software didn't just sit still. This era gave us time-sharing operating systems. So instead of waiting around for days for your batch job to finish, multiple users could sit at terminals and talk to the computer interactively, all at the exact same time. It felt like you had the whole machine to yourself. That's what made things like live airline reservation systems possible. Plus, around 1969, companies like IBM did something wild. They started selling hardware and software separately. Believe it or not, that one single business move basically sparked the entire independent software industry as we know it today. All right, we've made it to part 5, Generation 4, the microprocessor. This is where things get really personal. By the mid-70s, component density was just exploding, doubling basically every year. We jumped from large-scale integration, which was like 30,000 components on a chip, straight into very large-scale integration, or VLSI. You guys, we are talking about cramming literally 1 million electronic components onto one single microscopic chip. By pulling that off, they created the microprocessor. They literally managed to squeeze an entire computer's brain, all the logic, the math, the control circuits, onto one tiny, super affordable piece of silicon. And that miraculous shrinking act is what finally gave us the PC, the personal computer. Suddenly, all that computing power wasn't just locked away in some massive corporate basement. It was sitting right on our desks. This is the era that brought us semiconductor memory, those classic portable floppy disks, and of course, local and wide area networks. For the first time ever, computers could actually talk to each other and share data all over the globe. It's pretty wild, right? We've watched these things go from sweltering, failure-prone, room-sized monsters down to the sleek, connected powerhouses we use every single day. But here's the thing, the timeline doesn't stop. When you look at this crazy trajectory, this relentless journey of finding solutions to impossible problems, it makes you wonder. If they could fit 1 million components on a chip back in the 4th generation, what kind of unimaginable superpowers await us in the 5th generation? Something to think about the next time you look at the device sitting in front of you right now. Thanks so much for tuning into this explainer and keep on learning.